Download this code and get free GPT-4o from codegive.com, link in the description below. Java Reflection is a powerful feature that allows you to inspect classes, interfaces, fields, and methods at runtime, without knowing the names of the classes, methods, etc., at compile time. This can be particularly useful for various scenarios, such as testing, debugging, or even implementing frameworks. In the context of a hackerrank challenge, you might be required to access private fields or methods of a class using reflection. Below is a tutorial that explains how to use Java Reflection with a code example that simulates a typical hackerrank problem. ###tutorial, Java Reflection. ###basic concepts. 1. Reflection, the ability to inspect or modify the runtime behavior of applications running in the Java Virtual Machine, JVM. 2. Classes and methods. Reflection allows you to get information about the classes and methods at runtime, including private ones. 3. Access modifiers. Normally, private methods and fields cannot be accessed from outside their class. Reflection can be used to bypass this. ######Use case example. Let's say we have a class student with private attributes and we want to access these attributes using reflection. Here is a simple implementation. ###step-by-step code example. 1. Create the student class. 2. Create the reflection class. This class will use reflection to access the private fields and methods of student. Explanation of the code. 1. Creating an instance, we create an instance of the student class. 2. Accessing private fields. We retrieve the fields using getDeclared field. We set the fields accessible using setAccessible, true. We retrieve the values using the get method. 3. Accessing private methods. Similar to fields, we get the method using getDeclared method. We invoke the method using invoke, after making it accessible. ###output. When you run the reflection demo, you should see the output like this. ###conclusion. Java Reflection is a powerful tool that can be used to inspect and manipulate classes and objects at runtime. It can be particularly useful in scenarios like testing frameworks, ORM tools, and more. However, it is essential to use reflection judiciously, as it can lead to code that is harder to read and maintain. Always consider alternatives before resorting to reflection. This example should give you a good foundation to tackle Java Reflection-related challenges on platforms like hackerrank. Sure. Java Reflection is a powerful feature that allows you to inspect and manipulate classes, methods, fields, and other elements of the Java programming language at runtime. This can be particularly useful for tasks such as debugging, testing, or implementing certain design patterns. ###overview of Java Reflection. 1. Accessing class information. You can obtain information about a class, including its name, methods, fields, and constructors. 2. Manipulating objects. You can create instances of classes, invoke methods, and access or modify fields. 3. Dynamic behavior. Reflection allows you to create more dynamic and flexible programs that can adapt to changes at runtime. ### common use cases. Inspecting class properties at runtime. Creating instances of classes without knowing their names at compile time. Invoking methods dynamically. Accessing private fields or methods. ### reflection in Java. Here's a brief outline of how to use reflection in Java. 1. Get class object. Use class.forName, class name, or className.class. 2. Access fields. Use getDeclared field, string name, or get fields. 3 access methods, use getDeclared method, string name, class, parameter types, or get methods. 4 create instances, use new instance, on the constructor object. 5 invoke methods, use invoke, object, args, on the method object. 6 get/set field values, use get, object, and set, object value, on the field object. ### example problem, attributes reflection hackerrank solution. Let's consider a sample problem where we need to use reflection to access private attributes of a class. Assume we have a student class with private attributes and we need to print these attributes using reflection. ### sample student class. ### reflection example. Here's how you can use reflection to access the private fields of the student class and print their values. Explanation of the code. 1. Creating an instance, we create an instance of student using its constructor. 2. Getting class object, we retrieve the class object for the student instance. 3. Accessing fields, we access the private field's name and age using getDeclared field. 4. Setting accessible, we use setAccessible, true, to bypass Java's access control checks. 5. Getting field values, we retrieve the values of the private fields using get. 6. Printing values, finally, we print out the values of the attributes. Conclusion. Java Reflection is a powerful tool, but it should be used prudently due to performance overhead and potential security issues. It's particularly useful in scenarios like testing frameworks, serialization libraries, or where you need to interact with unknown classes at runtime. Always be cautious when using reflection, especially to access private members, as it can lead to code that is harder to maintain. This tutorial should give you a good start on using Java Reflection in practical scenarios, such as solving problems on platforms like HackerRank.